Hello everyone and welcome to Danomics. In this video we're going to review how to do a water saturation interpretation. Uh, as part of this we'll choose the saturation model that we want to use, we'll evaluate the Pickett plot, and then we'll select the permeability method that we want to use. Let's get started. So at this point you should have already created your CPI file. You should have selected your key well and make sure that it's your active well since we're going to be setting some parameters. You will have already performed your clay volume, TOC analysis, and porosity interpretation, and optionally your mineral inversion. And so now we're going to select to do the water interpretation. So when we look at this here, we have a few different options here for our water saturation method. We have the Archie, Siemens-Dew, Modified Siemens-Dew, Indonesian, dual water, and Waxman-Schmidt methods. Based on the method that you choose, that'll determine which parameters you see with respect to your A, M, and N values. You'll also be presented with options for your permeability method, where we have the Wiley-Rose, Coates, Timmer, Tizier, and Heslop methods. Okay, so for this interpretation, I'm going to choose to use my Archie total porosity method. And when I do this, I'm selecting that for every zone. I can choose, whichever method for whatever zone, so we can have as many variations as we want there. And I'm going to leave my permeability method at the Wiley-Rose for right now. Now there are a few things we need to do as setup to this. So first of all, we need to put in a surface temperature. This is up in Wyoming, and the surface temperature is around 60 degrees for this area. And we need to set a geothermal gradient. The geothermal gradient out here is around 1.1. So I'm going to make those. And the reason we do this is because all our calculations are going to be converted to downhole temperatures. So now we're going to choose a cross plot, and we're going to select the Pickett plot here. And I'm going to make this a little bit bigger so we can see it here. And when you make a Pickett plot, this is a plot of total porosity on the y-axis versus resistivity on the x-axis, and this is in log scale. Now, in general, we'll want to look at this for a limited number of formations at a time. And so I'm going to start off by looking at the Teapot and Parkman formations. And if I want to color those by zone, I can indicate to color by zone. It's often also useful to filter your Pickett plots to only show reservoir quality data. In this case, we can use the filter, and I'm going to filter out samples that have high V clay. So I'm going to say at VWCL less than or equal to, and I'm going to say 45% here. And we'll see that this cleans up a little bit of data that's available to us. Okay, so with the Pickett plot, what we want to do is we want to have the 100% line going through the data where we believe the water saturation is 100%. So there are a few adjustments that we can make here. So first of all, do we know the resistivity of the formation water at surface? I happen to know out here that at our reference temperature of 60 degrees, our RW is about 0.15. Okay, and now that we've got that set, now we can adjust the M value. M controls the slope of these saturation lines. And I'm going to set M to be about 1.8 in this case. And so now our 100% saturation line is running through the data here. If I had core data that allowed me to set this, I would also set the N value in this. And you'll notice that as we change this, it updated the interpretation for our water saturation. I would now go through and I would repeat this process for each of my formations. So let's say we wanted to look at it for the Sussex and the Shannon. Here, and you'll notice this trend is more vertical, and this is due to the high clay content within the Sussex and the Shannon. And let's look at some of our other formations like the Niobrara, Carlisle, Frontier, and Maori. So we can also set those and adjust the picket plot as needed for this interpretation. If we wanted to use an alternative method, let's say, for example, we felt we had some high clay sands here in our Parkman formation, we could come to the Parkman and we could choose a method such as the modified Siemens-Do. Modified Siemens-Do uses a clay resistivity, and what we'd want to do is look at our RT clay plot, select our Parkman formation. Sorry, I chose the wrong plot here. Let me choose the RT clay, and we'd look to see what our clay resistivity is. It's about 3.5 to 4 ohms. Let's say I wanted to update that to somewhere in that neighborhood. Now I could come back and I could look at my picket plot, and I'll see that this resistivity profile has now been updated to use the modified Siemens-Do parameters. For my permeability, let's hit the advanced button here, and this will show us our values here for permeability. These are essentially scalars here, and if you click on the help, it'll show you the formulation for this and how you can change this. The parameter that you're most likely to change here is this p-value. And if I were to have core data that told me, for example, that my permeability needed to be lower, I might change this p-value, in this case, to around 2.5 and reduce what my permeability is here. If I need to change the scale to look at that, maybe I could change that to go from 0.01 to 100 millidarcies in this case. And so that is all we have to do to perform a water saturation interpretation within Danomics. If you have any questions, please feel free to send us an email at support@danomics.com. Thank you.